Alright guys, so today we're going to do the 2008 paper question 4. So we're looking at developments in solids in contact. So I picked this one here. Reason being, we have a solids in contact within it and the developments. And there's one thing here that I don't think we've seen before, but there's no reason why it wouldn't come up in the question 4 or question 1 or somewhere else, where we're given a plan and elevation and we're not actually given the width of the elevation. So it would have caught a lot of people doing it because they would have been so used to being given the measurements, you know, the widths and heights. They don't have to be given to you in an elevation, or they don't have to be given to you in a plan. There might be some way to work it out. Okay, so in this particular question, we'll just give it a read here. So the figure shows the elevation and incomplete plan of 3 solids in mutual contact. Okay, so just a minute there. So we've shows the elevation. A pictorial view of the solids is also shown. So here's our pictorial view. Draw the completed plan and elevation, showing clearly how to locate the center of the hemisphere in plan. Show all points of contact, points and lines of contact. So we've got a hemisphere that's sitting here at the front that isn't shown in plan. We've got a cylinder, and we've got this kind of like a rounded rectangular prism that's coming up from the bottom. So part B is going to be draw the development of surface A of the truncated cylinder. Alright, so we'll have to look at this plan elevation. So we've got height of 75, we don't have a width. This is one of these situations, lads, where you're going to have to recognise that I don't have what I'm going to have to do is start with the plan. So I have all the measurements in the plan, so I'm going to have to start with that. So, there again. Okay, so what I'll do is I'll start with the box that rounded rectangle goes into, and I do have the measurements of that, so it's going to be 110 by 65. So the height of the overall thing, it's not going to go any higher than 75. So look, if I come down 90, I'd be sound there. So I come down 90. Okay, so I'll draw my XY line, like that. Okay, and I'll come down 10. So I'll come in a good bit from the left, and I'll start with that, maybe the top left corner of that box. Top left of that box is, so I'll put it there, and I can see that it says there's an angle of 30 here that it's inclined at, so that's 30, the rest of it is 60 to make that 90 degree angle. So I'll just draw down 60 degrees, and if it's 90 degrees to that, I can use the 30 degree on my set square to draw that. Okay, so I have 65 in there. 65. Okay, and then I'm going 110 the other way. So that's the rectangle. So I'm going to be drawing this in 2H because there's rounded edges to the top. Okay. Okay, so there's my rectangle. The thing is going to make it a little bit darker there so you can see it. Yeah. Okay. Right. So this rectangle that it's going into has rounded edges. The size of them, the radius of them rounded parts are 15 millimeters. So to get that, I'll have to come in 15 and 15 from both sides. 15. Okay. 15 there. Okay, and I can use that to come in 15 from the other side as well. Okay, so that's 15, 15. So we just have to mark that off already. Just have to draw that across. Okay, so we have the centre of all the them rounded parts that we need and the points of contact. So let's just draw 15. That's the first one. Second one. Third one. And finally the fourth one. Okay, so there are rounded edges. Okay, so there are rounded edges. And we'll just finish it off because the whole lot of this is staying, so we'll just finish it off. So put it in the edge. Right. Okay, so now we have the kind of rounded rectangular prism thing drawn. So now we can we have the width of the final piece, or the width of it in elevation. So if I'm looking at elevation, that's the width of it. So I just need to see what's the last thing I'd see on the right and the left. So I'll go from the centres of them rounded, them arcs, the centres of them arcs. So that point there will be the last one I'd see over here. So I project them up, straight like that. And that point there will be the last one I'd see here. So I project them straight up. Okay, and then the height up here is 75. There we go. 75. And just draw that right across. So now I do have the rectangle that's going into. Okay. Right. So after that, I'll draw. I just need to project down this line. Project down like that. So I need to draw this circle that goes in here, which is the plan of the cylinder, and it's a radius of 15, which means I have to go 15 in from here, and that circle is also touching this line, so I have to go 15 in from there, perpendicularly. So if I measure in, I actually already have 15 in from there, because I have it on that line there. If that's a radius of 15, but that's a distance of 15, I can also just draw a horizontal line, put 15 on it. So that's going to be 15 away from that line. And then I'm going to draw a perpendicular line here, away from that edge, and I'll mark off 15 on it. Mark 0 there, okay. And now I have a line 15 away from that edge. There, like that. So now I have a point that's 15 away from there, 15 away from there. So if I put in 15 on my compass, a radius of 15 millimeters on my compass, it'll be the same as that, isn't it? Okay. And now I've got a circle that touches. There we go. So there's our circle touching off that line and that line. Okay, so I get the outside generators to the far left and far right of that cylinder. In other words, what's the rectangle I'll see if I'm looking straight in that cylinder? Well, that's the far right of it that I'll see, so I'll project that up, and the far left is going to be also on top of that line. So there's the cylinder there, the outsides of the cylinder. If it wasn't truncated, it would be the full rectangle, but it shows me in the drawing that it's chopped off at 45 degrees. So actually, do not, I'll do that in H. So I'll do that as a working line. There it goes. And I'll draw in the amount. So there's the far left hand side of that rounded rectangular prism. And this one up there. And I can draw this line across the top as well. So there we have, and look, I'm just drawing the start of this. I won't be able to draw the whole lot because there's a hemisphere in here. But look, there's the rounded rectangle prism that we have, and there's the cylinder sitting in front. It would go all the way down to the bottom if we didn't have this hemisphere blocking it. So the hemisphere, what's the story with that? Well, they tell us that the hemisphere is a radius of 35. So if you imagine you chopped a globe across the equator, or a sphere across the centre of it, the circle part that would be sitting on the ground is the biggest circle that I can make. So so that circle is a radius of 35. So in other words, I have to fit a circle in here that touches off both this line here and that circle there. So I think about the centre of that. So where is the centre of that going to be? Well, the centre of it is going to be 35 away from the circumference of the circle, and it's going to be 35 away from that line, perpendicular. So if I extend out that line just a little bit further from the centre of that circle, and I add the radius of 35 onto it, I'll do the same here. So I'll add 35 onto it. There's 35 there, perfect. And then I'm going to put 35, let's put it here, so there's 35, distance of 35 there. So I'll draw a line parallel to the one I want to touch, 35 away, and then I'll swing an arc that's 35 added onto the original radius away from the centre of the circle I want to touch. Okay, now I'm 35 away from that, 35 away from that, so that point there is the centre of the circle that I'm looking for. So 35 on my, I'm going to draw it in H. So there's 35, so I should touch off that. Just give it a quick check and touch off that. It's fine, so try that in. So there's my circle touching off there. So that's the base of that hemisphere that I'm talking about. Okay, one last thing to do, I'll get the point of contact. So join the centres here, will give me the point of contact in the bottom. And it's between a circle and a line, it's go perpendicular to the line. Through the centre of the circle, so that's perpendicular there. So I'll have my point of contact there. There's P O C. There is my P O C. Perfect. Okay, there's a line of contact missing. I'll get that there at the end. We'll have a look at it at the end. Okay. Right. So now that I have that circle drawn in there, I can draw it up in my, I have the centre of it up here. So if it's a sphere or a hemisphere, it's going to look like a semicircle up here, or if it was the full sphere, it look like a sphere. And I can see from the question that the centre of that that I'm looking for, the centre of that semicircle I'm looking for is 35, so it's going to be exactly the same as this. So that's the 35 I have. The centre is there, projected up, so that's the position of it up here. So I can draw in like that. There we go. Alright, so there's my hemisphere in there. And all I can do then is just finish off this cylinder. So now I can finish it off. So the cylinder is going down behind it. So imagine that hemisphere, if I'm looking in here, that hemisphere is blocking off the base of that, the bottom of that cylinder. So I draw it down as far as here. And then it turns into a dotted line. Okay, so there's our dotted line. So there's our elevation. We'll take up some of these points of contact, so we have to show them in elevation as well. So that point of contact is going to be on the ground. So I'll just project it up onto the ground. There it is there. So I'll just mark it in. There's my point of contact. the point of contact between the hemisphere and the cylinder is also going to be on the ground. So I'll take it up. There we go. Okay. Right, and now we're missing one line of contact. So the line of contact we're missing is between the cylinder and the cylinder and here. Look, the cylinder. So if you imagine a cylinder, there's my water bottle there. If I imagine this cylindrical part of it, if I put that on the board, it's not going to be touching it at one point. It's going to be touching it at a line. It's going to be touching it on a line. So where is that line? Well, I can see it in plan here. There's the cylinder touching off that. So remember, it's just a line and a circle in plan, perpendicular to the line through the centre of the circle. And that there, point there, gives me my LOC. So it's a line of contact, and I'm looking straight down top of the line. So draw it up here. There we go. So there's the line of contact up there. Try and put it in lightly. So that there is my LOC, line of contact. Alright, and I put that in because the X for line of contact. So it's actually behind it. That's where it is. Okay. Right. So that is the plan and elevation of what I'm looking for. All that I'm left with now, I'll just label in my XY. So what I'm left with now is part B, and part B is drawing the development of the cylinder. So nice and handy. Straight away I'm going to be thinking about generators. So if I'm dividing up a cylinder, well, straight away I'm going to have to divide the plan view of that cylinder, the circle view of that cylinder. I'm going to have to divide that up into 30/60. So I'll divide it up here. 30/60. A few lines on it now, so 30/60. So a few of these are already going through it. So we need different here. Okay. Is that everything? That is everything. Right, grand. Okay, so I divided up the circumference. I'll start labeling it. So I'll call this from a 0. Second one going at 30 degrees is 1, which is also on the line of contact. 2, 3, 4, 5. Bottom one is 6, 7, 8, 9, 10, 11. Alright, so there's the circumference divided into all them points, and them points are me looking down the top of generators or lines that make that shape. So if I project them up, I can actually draw them. So there are the generators along it. So if that cylinder was full, the generators would be going all the way to the top. So I'm going to draw them in for the time here. So I'll draw them going all the way to the top. So there's 7 and 11. There's 10 and 8. And okay. So if that cylinder was full and not chopped off by that 45-degree plane, they would be full. 0 to 11 or 0 back to 0 would all be full generators, but they ain't. What's the story with them? Well, that's the length of them. The length of them that are left, I'll draw them in pink. So this pink line. This one is the same as the line of contact, so it'll be pink and purple. This line there. Stay here. Stay here. There we go. Alright, so now that's how much is left of them generators. I'll just label them. So we have 3, then we have 4 and 2, then we have this one up higher, 5 and 1. This one down here is 6 and 0. This one up here is 7 and 11. This one here is 8 and 10. And the last one is 9. Okay, so there I have all my generators there going down. So, same as what I told you before. So if I'm developing out, a 3D shape, I'll think about developing to the full thing first. So this one here, number 3, the generator 3 is actually would be the size of all the generators if the thing wasn't cut. So I'm going to project them out because it's common to all of them. So I'll project them all out there like that. And okay, now, so that would be the height of them if they weren't there. So I'm going to produce all these generators along here. What's the distance between each generator? Okay, it's here. So I decide somewhere to start. So I'm going to start with, what's the end of this thing? I'll start with 3. So I'm going to make this 3 here. So 3 is a full generator. So I'm going to draw that one going all the way up to the top. 3 is the full generator, and then I'll take it from there. Alright, so I have 3. What's the distance between 3 and 4? Well, the distance between 3 and 4 and 4 and 5 and 5 and 6 are all the same. There it is there. So I'll mark it out. So I've got, there's 3 to 4, 4 to 5, 5 to 6, 6 to 7, 8 to 9, sorry, 3 to 4, 4, 5, 6, 7, 8, 9, 10, 11, 0, 1, 2, and don't forget you have to go back to 3. Imagine this joined together, you have to have 3 joining to 3 to make it a full shape. So we'll just label them. So we've got 4, 5, 6, 7, 8, 9, 10, 11, 0, 1, 2, and then back to 3. 3 will join back to 3. Now if you start with 0, you can start with whatever you want. Just make sure whatever you start with, you end with that as well. Okay, so now I've got all my generators, and I'll draw them all in fully as if they were all there. And like I said before, 3 is fully there, so I can actually draw that in fully. Okay, there we go. And I'll draw 4 in fully, 5 in fully, 6 in fully, 7, 8, 9, 10, 11, 0, 1, 2. Okay, so if I cut out that and rolled it around and made a cylinder out of it, that would be it. It would be the full cylinder. But as I know, all them generators got cut. So here's where 4 and 2 got cut, up here. So I'll mark that in. 5, 4 and 2. 5 and 1, cut there. 5, 1. 6 and 0, got cut here. 6, 0. 7 and 11, up there. 7, 11, 8 and 10, 8 and 10, 8 and 10, and then there's 9 here. There we go. So that's how much was left of all them generators. Look, I'll draw them in pink. So just that they correlate to that. Hunt up to there. So that's how much all of them generators are left. 10. So that's how much of all the generators left. So now we're able to draw the development. So if I just do my very, very light hairline first. Okay, so it makes kind of a curve. 1H line. So there we go. And I just adjust just so it's one shape. 3. So there's our development of that truncated cylinder. Alright. Hey lads. You can put them in colour if you want, you don't have to. Just get the development, the plan elevation development done. Make sure and show the line of contact, 2 points of contact, and get the development done.